In this video, we are going to be looking at the Greek word. Join us as we dive into the rich history and significance of alpha and beta. Discover how these alpha and beta, which are the ancient symbols, shape the world of mathematics and science. When we said alpha, it's written this way. Alpha is being denoted by this symbol. What about beta? Beta, and this is the symbol for beta. Sometimes dependent, sometimes something like this. It's just the same thing. So let's start with the first one, which we said alpha. Notice that alpha is the first letters of the Greek alphabet, signifying beginning and leadership. In mathematics and science, it is used to represent various concepts such as angle and coefficient, and signifies some levels in statistics. Let's take some few formulas and see which formulas can we possibly find this alpha. The first formula which I can remember is alpha bending formulas in computer graphics. In this case, alpha has been denoted by, you can find alpha, this is the formula, C result is going to be alpha multiplied by C foreground. You are going to plus that by the bracket of 1 minus alpha. You are going to multiply that by C background. Let's take this to be A, and another formula which we can possibly find alpha is coefficient of linear expansion. In physics, this formula is given by delta L is equal to alpha. You are going to multiply that by L naught. You are going to multiply that by dt. Notice that the delta L simply stands for change in length. The L naught simply stands for original length. And we have the delta T, which simply stands for change in temperature. The temperature can be in degrees Celsius, can be in Fahrenheit. But if we are to apply this change in temperature, let's start with the first one. Change in length is simply going to be L2 minus L1. What about the change in temperature? Something is going to be T2 minus T1. So for the L naught, it's simply going to be L naught. So the next formula, which I can remember right now, is the formula for area of triangle using the length of its side A, B, and C. Let's say we have a triangle here, A, B, and C. Let's try the Henron's formula. Let's say Henron's formula. In this case, notice that if this is alpha in capital letter, this is also alpha. This formula says that alpha is going to be the square root of S into bracket of S minus A. Remember to multiply that by S minus B and multiply that by S minus C. That is these variables, A, B, and C. In this case, notice that the S, this is simply semi-parameters, which means our S is simply going to be A plus B plus C. We're going to divide everything by 2. So let's look at for beta and look at some formulas which we can possibly find beta there. Let's say beta. Beta, let's put down the formula. So in this case, when we talk about beta, beta is simply the second letter, symbolize contrast or alternative options. In finance, it is used to represent volatility in stock and investment portfolios. It is also used in physics to denote phase shifts and in computer science for testing softwares before fully released. So let's take some few formulas which we can possibly find our beta there. In finance, the beta of stock measures if volatility relative to market. The formula to calculate the beta is given by, here we're going to have formula for calculating beta in marketing problems. This COV simply stands for covariance. So here we have Rs, comma, Rm. I'm going to divide that by VAR into bracket of Rm. Before I move further, this COVR simply stands for covariance. And here we have two problems. The RS simply stands for stock return. This is stock return. And the RM simply stands for market return. And notice that here we have VR, which stands for variance. We are going to divide everything by variance in what? The market return, which we are going to substitute this into this. So this is it for this problem. But let's look at another formula, still under the beta. We have another formula which is beta distribution probability density. It's given by F in the bracket of X as A and B is equals to X A minus 1 into bracket of 1 minus X to the power of B minus 1. We're going to divide everything by B into bracket of A, comma B. In this case, notice that the X is random variables. If X is random variable, what about A and B? Are the shape of parameters. Then the last thing we have, which is B into bracket of A, comma B, this is what we call the beta function. So let's look at the last formula, and we shall call it a day. The last formula is for beta decay formula in nuclear physics. This formula is being given by N into bracket of T, which is going to be N naught. I'm going to multiply by E minus lambda T. Notice that the N into bracket of T is the number of radioactive atoms at time. Because of this T, what about the N naught? The N naught is initial numbers of radioactive atoms. Then the last one, which is the lambda, is the decay constant. So this is it for this problem. I hope you find it helpful. Feel free to like, share, and subscribe, and see you next time.